Okay, guys, so today we're going to talk about how do you know if a single replacement reaction happens. Just because you put two chemicals together doesn't mean a reaction occurs. And so today we're going to look at, will the reaction happen? How do you decipher that? And you've done the activity lab, the metals activity lab, where you classified what metal is the strongest, what metal is the weakest in the activity series. And so we have over here on the right side, we have a more complete activity series that you can look at over here that we'll be looking at to do this. And so effectively, to solve or to understand if a reaction occurs, is you want to compare the two metals. And if the metal that's by itself, for example in this first problem, lithium is by itself, if it is higher, and here's lithium right here, if it is higher in the periodic, or not the periodic table, higher in the activity series than the other metal, aluminum, for example, in this case, which is down here. So we have our lithium up here and our aluminum down here. If it's higher, then it will occur. And if the lone metal that's by itself is lower in the table, then the reaction won't occur. And so in this case, since lithium is higher in the activity series, it's more active, it's more reactive than aluminum, then the lithium will react with the aluminum sulfate and we'll have a reaction occur. So in this case, we will react. We'll get the aluminum get kicked out of the compound, and we'll get a lithium sulfate compound form. And so you'll see the aluminum metal. If you actually were visualizing this reaction, you would see the aluminum metal deposit itself on the lithium metal as it reacted. Second example, let's go through that. So we've got magnesium here, and the metal would be the hydrogen. Even though it's not a metal, it's the first one written. And so can the magnesium replace the hydrogen? So you need to go and find the magnesium, and magnesium's right here, and hydrogen is down here. And so the magnesium is higher than the hydrogen, and so the magnesium can replace the hydrogen, and so it does so. The hydrogen gets bumped out. Since hydrogen is diatomic, it will be H2, and the magnesium will combine with the chlorine. Magnesium has a charge of 2 plus, and chlorine has a charge of 1 negative, and so when you crisscross those, you get an MgCl2. Another example, iron. Can iron replace the copper? And so go and look for those two in the table. So iron is right here, and copper is down here. So can iron replace the copper? Yes, it can. And so it will do so. And so the iron kicks the copper out. We end up having copper plus iron nitrate. Let's say this is going to be an iron 2 nitrate, so that would be FeNO3 2. And so just to make it easy on us, on you, as you do these reactions, if you do have a transition metal replacing something in a compound and you're not really sure what to put down, just make it the same charge as what you replace. We'll not do oxidation reduction here, reactions here. And so make it the same charge. So we'll keep it as a 2 plus because copper was a 2 plus here. All right. Let's look at this one, chlorine and sodium iodide. So this one's a little bit different because chlorine is a nonmetal. That's a nonmetal. So it's going to go over here and replace the nonmetal iodine. But if you look on your list, these are all metals in our list. So how do we know what the nonmetals do? Well, what you do with the nonmetals is you look on the periodic table. And the higher an element is in the periodic table, the more active it would be. Actually, let me clarify that. We're only looking at halogens, not any other nonmetals. So and we'll only do halogens, so on our nonmetal replacements. And so look at your halogens, chlorine and iodine. Chlorine is higher on the in the family than iodine is, and so chlorine will replace the iodine, and we will get the iodine coming out by itself. It's diatomic, so it needs a 2, and we'll have the sodium and the chlorine combined to make sodium chloride. On this one, you have bromine is going to try and replace the fluorine. Well, fluorine is higher than bromine in the periodic table in the halogen family. Fluorine is the first halogen, the topmost halogen. So bromine is not strong enough to do so, and so we'll get a no reaction here. If you get any elements, if any of these would be lower instead of higher, then you just get a no reaction. Just write NR for no reaction. And so that is how you predict a single replacement reaction. If the lone element over here is higher than the element that it's going to replace, higher on the activity series or in the periodic table for the halogens, if it is higher, then the reaction will happen and you need to do the single replacement reaction. If it's lower, then there's no reaction and you just write NR next to it, because those two elements or those two compounds will sit there and not do anything. Okay, so that is a quick lesson on how do you know if the reaction will happen. And then once you know if it happens, then you need to do the reaction and you would need to balance these. These would all need to be balanced. We haven't balanced them. So you would complete the reaction and then balance the equation to take care of your coefficients. Okay guys, that's it.